Before the first human voice broke the silence, before the first spark of fire lit the darkness, the Earth had already turned for hundreds of millions of years, alone. Forests, older than our species, swayed in winds unmeasured by any clock. Oceans without ships rolled endlessly against shores no foot had ever touched. The world's mountains rose and fell in slow breaths of stone, and continents drifted like sleepwalkers across the surface of a restless planet. If there had been eyes to see, they might have witnessed more than just the slow crawl of evolution. They might have seen something different. Cities that once rose where jungles now stand. Towers of glass and metal now ground into dust. Roads erased by the grinding march of glaciers. Entire civilizations built, destroyed, and then swallowed by the patient work of time. Civilizations, like sandcastles, are temporary things. No matter how intricate, they are claimed eventually by the tide. And the tide of geological time is not measured in days, but in millions of years. Scientists call it the Silurian Hypothesis, the unsettling possibility that another intelligent species, long before humans, may have risen to mastery over the planet, and then vanished so completely that only whispers remain in the rocks. Could the Earth itself be hiding memories it will never tell us? Could the crust beneath our feet and the depths of our oceans be keeping the secret of a forgotten epoch buried beyond recognition? The story of humanity might not be the first chapter in the Earth's book of intelligent life. It may simply be the first chapter we can still read. The Earth is an archivist, but not a perfect one. Its records are written in stone, in ice, and in the slow layering of sediment at the bottom of oceans. Every grain of sand, every mineral vein, is a word in a language millions of years old. To read it is to step outside human time and enter the planet's memory. For centuries, geologists and paleontologists have been deciphering that memory. They have uncovered the violent punctuation marks of asteroid impacts, the smudged lines of ancient shorelines, and the faint, almost imperceptible signatures of vanished climates. In doing so, they have learned to think on a scale far beyond the rise and fall of empires. But some pages in Earth's archive are blank, not because nothing happened, but because time is ruthless with its editing. Entire ages are compressed into a few centimeters of rock. Entire landscapes vanish under the churn of plate tectonics. It was in contemplating these blank pages that two scientists, Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, and Adam Frank, an astrophysicist at the University of Rochester, posed an unsettling question in 2018. If another technological species had arisen on Earth millions of years before us, would we even know? They called it the Silurian Hypothesis, borrowing the name from a fictional race in a British science fiction series, Intelligent Reptilians Who Predated Humanity. The name was playful, but the question was serious. They began with geology's most basic premise. The deeper you go into the Earth's crust, the older the record you read. Ice cores store chemical signatures of the atmosphere going back hundreds of thousands of years. Sediments at the ocean floor hold clues to global temperatures, vegetation patterns, and even catastrophic events like supervolcano eruptions. In these records, certain anomalies stand out. For example, abrupt spikes in carbon isotope ratios that suggest massive releases of greenhouse gases. Layers containing synthetic compounds that nature does not produce in abundance certain forms of plastics or industrial byproducts. Concentrations of heavy metals in quantities not easily explained by volcanism or meteor strikes. Most of these anomalies in known history align with the Anthropocene, our own geological fingerprint. The layer of plastics, fly ash from coal combustion, and isotopes from nuclear weapons tests that will mark our time in the rock record for millions of years. But Schmidt and Frank asked, what if something like this happened before and was erased? Consider the Paleocene-Eocene thermal maximum, PETM, 56 million years ago, a sudden dramatic spike in global temperatures and carbon levels. Mainstream science attributes it to volcanic activity and methane release. But could an industrial civilization, now lost, have been a contributing factor? Or the Carboniferous period, 300 million years ago, a time when dense forests blanketed the continents, laying down the coal beds we mine today? Could a species have arisen then, burned its own resources, and triggered climate shifts long forgotten? The Silurian Hypothesis is not a claim that these events were caused by ancient civilizations. It is an exercise in forensic humility, a recognition that deep time has a way of erasing almost everything. Stone erodes, metals corrode, and organic material decays. Even our tallest skyscrapers, left untended, would crumble to nothing in less than 10,000 years. Given 1,000,000 years, only the faintest chemical traces might remain, if they survive at all. To hunt for those traces, scientists look for what they call technosignatures, markers of technology that are unlikely to occur naturally. These could include unusual isotope ratios, such as enriched carbon-12 or nitrogen-15, indicating industrial-scale processing. Synthetic compounds, like certain chlorofluorocarbons, which have no natural source and persist for tens of thousands of years. Persistent heavy metals, concentrated in ways inconsistent with known geology. But here lies the challenge. Over millions of years, the Earth is not static. Continents drift and collide. Ocean floors are recycled into the mantle through subduction. Glaciers grind landscapes into dust. Volcanoes bury entire regions in molten rock. And with each cycle, the evidence of the past is rewritten, overwritten, and often lost forever. Yet the search continues. Cores drilled from deep beneath the Antarctic ice reveal layers of volcanic ash and traces of ancient atmosphere. Samples from the abyssal plains of the Pacific carry microscopic fossils that tell of vanished ecosystems and shifting ocean chemistry. These are not smoking guns, they are the faintest of whispers, the geological equivalent of footprints in wet sand, half erased by the tide. Even more tantalizing is the possibility of finding ancient anomalies beneath the oceans. During ice ages, sea levels dropped hundreds of feet, exposing vast stretches of continental shelf where early civilizations, human or otherwise, might have lived. Today, those shelves are drowned, their ruins buried beneath sediment. To explore them is to embark on a mission both scientific and philosophical. It requires asking questions that challenge the deeply held belief that humanity's intelligence is unique, recent, and inevitable. Schmidt and Frank did not set out to prove that ancient civilizations existed. They set out to test our ability to detect them, and what they found was sobering. Even if such civilizations had existed tens of millions of years ago, the odds of finding unambiguous evidence today are vanishingly small. This realization shifts the question from, did it happen, to, could we ever know? A question that lingers like an echo in the deep corridors of geological time. In the end, the discovery phase of this mystery is less about finding ancient ruins than about revealing the limits of our own perception. The Earth is a palimpsest, a manuscript, rewritten countless times. And somewhere, deep beneath its newest lines, there may be words from a chapter we will never read. The idea landed in the scientific community not with a thunderclap, but with a cold, quiet weight. The kind of realization that does not shout, but lingers. It was not a claim of discovery. It was something more unsettling, a fracture in the way we imagine ourselves. For centuries, human culture has rested on an unspoken assumption that intelligence like ours is new, that we are the culmination of Earth's long evolutionary story. From the first chipped stone tool to the algorithm steering our satellites, we imagine an unbroken ascent, a single thread stretching from the dawn of humanity to the stars. The Silurian Hypothesis does not sever that thread. It shows us how fragile it is. If a civilization had risen and fallen millions of years before our own, the evidence, cities, technology, art would almost certainly be gone. not just buried, but erased by the constant recycling of the planet's surface. Plate tectonics grinds continents into magma. Rain and frost shatter stone into dust. Ice ages sculpt valleys where mountains once stood. In less than 10,000 years, nature reclaims every monument. In a million, the record is gone. The shock is not in the possibility that others came before us. The shock is in realizing how quickly we, too, could vanish from the story. Geologists call it deep time, the almost incomprehensible span in which mountains rise and fall like waves, oceans open and close, and continents dance slowly around the globe. Against this backdrop, human history is barely a flicker. The pyramids of Giza, the Great Wall, the skyscrapers of New York, all of them exist in a thin surface layer, no thicker than a coat of paint on a cathedral wall. And yet, within that layer, we find the proof of our existence. Plastics in the soil, radioactive isotopes from nuclear testing, synthetic fertilizers embedded in sediments. If these signals persist for millions of years, they will mark our moment in the geological record. But Schmidt and Frank's unsettling point was this: if another species left a similar signal in the distant past, we might not recognize it for what it was. This is where science meets discomfort. Because the possibility of a forgotten civilization is not merely a curiosity, it is a mirror. If they existed, they failed. And failure, in this case, means disappearance so complete that even memory itself is lost. The anthropocentric worldview, the belief that intelligence is rare, special, and perhaps inevitable, begins to fracture under this possibility. Evolution is opportunistic. It does not climb a ladder toward a predetermined goal. Intelligence, as we define it, may have emerged before and may emerge again long after we are gone. But why is it so hard to believe? Because in our minds, civilization is a linear story. We imagine a beginning fire, language, agriculture, and a rise toward ever greater complexity. We rarely imagine that the arc could bend back toward zero. And yet, history gives us warnings. These are local collapses, but they show how fragile the structures of civilization are when faced with climate shifts, resource exhaustion, or catastrophe. Now scale that fragility across millions of years. The Earth has endured extinction events far greater than anything humans have faced. The asteroid that ended the dinosaurs, the Siberian Traps eruptions that nearly sterilized the planet 252 million years ago, sudden climate shocks that reshaped oceans and atmospheres. In each case, entire ecosystems were reset. In such an event, the artifacts of a civilization would not survive, not in any recognizable form. Here is the paradox that stunned scientists. The absence of evidence is not evidence of absence. We may look into the ancient rock record and see only the marks of volcanoes and asteroids, when in truth, something else may have added its signature. Something intelligent, technological, and gone. Even if we did find an anomaly, a strange isotope ratio, a synthetic compound in an ancient layer, how would we interpret it? Without context, without artifacts, we might call it a quirk of geology. A clue without a crime scene. And here lies the quiet terror. Our own future may leave the same kind of lonely clue. If humanity disappeared tomorrow, the cities would crumble, the satellites would fall, and in a geological blink, the only traces of us might be chemical oddities in the rocks. To a species millions of years in the future, we might appear as nothing more than an unexplained carbon spike, a thin layer of plastic dust, a whisper that once, briefly, the Earth dreamed in circuitry and light. The Silurian Hypothesis forces a shift in perspective. It asks scientists to see the rock record not just as a natural history, but as a palimpsest, a reused parchment where old words are scraped away and new ones written over. In such a manuscript, faint traces of older writing can survive, but they are fragile, ambiguous, and easily missed. This is not an easy idea to absorb. It challenges the foundation of disciplines built on continuity, paleontology, archaeology, anthropology. It invites the possibility that human uniqueness is an illusion born of ignorance, that we are not the first to stand at the edge of space and wonder about the stars. And perhaps most unsettling of all, if it happened before, it could happen again, not just here, but on countless worlds. The rise and fall of civilizations might be as common as tides invisible when viewed from afar, inevitable when seen in the context of cosmic time. In that context, our moment feels both precious and precarious. We are not the center of the story. We may not even be the first page. The rock record is a manuscript, and scientists are its quiet readers, searching for the faintest residue of forgotten ink. Unlike any human archive, the Earth's script is not linear. It is layered, rewritten by wind, by water, by fire, and by time itself. The Silurian Hypothesis demands a new kind of reading. If a civilization had once risen, fallen, and been ground to dust tens of millions of years ago, its ruins would be gone. Its monuments melted into the crust. Its machines oxidized into nothing. What would remain? Only what could outlast the elements, survive cataclysm, and persist in the quiet chemistry of the planet. Gavin Schmidt and Adam Frank called these remnants technosignatures, traces of technology, embedded in the geological record, surviving far beyond any artifact. The search for them began not with temples or tools, but with signals written in chemistry and isotopes. The most promising archives lie deep beneath oceans and ice. In the abyssal plains of the Pacific and Atlantic, fine sediments drift down year after year, forming layers as thin as pages. At depths of thousands of meters, the seafloor is stable, undisturbed by waves or storms. Here, under immense pressure, the record is preserved in uninterrupted sequences stretching back tens of millions of years. Coring vessels lower drills into the ocean floor, bringing up cylinders of ancient mud and silt. Each core is a time capsule, the upper layers representing recent centuries, the lower sections marking epochs when the continents were in different positions, and the sky held unfamiliar constellations. In these cores, scientists search for anomalies, chemical fingerprints that nature rarely leaves. Plastics, though most degrade quickly, can fragment into microplastics that become locked in sediments, especially in anoxic layers where oxygen cannot reach them. Synthetic chemicals, such as certain halogenated compounds, have no known natural source and could persist for tens of thousands of years. Industrial processes leave characteristic shifts in the abundance of isotopes, like carbon-12 versus carbon-13, or nitrogen-15 versus nitrogen-14. Detecting such ratios in ancient layers could hint at large-scale manipulation of the biosphere. Ice cores preserve a different kind of memory. Air bubbles trapped in ancient ice record the atmosphere of their time, holding samples of greenhouse gases, traces of heavy metals, and clues to global temperatures. A sudden, unexplained spike might point toward industrial activity. Yet the ice is a short-term witness. Its record fades after hundreds of thousands of years, making it useless for civilizations that may have vanished millions of years ago. Stone, however, can remember longer. Limestone beds capture the chemistry of ancient seas. Shales preserve organic molecules from the environments in which they formed. Even clays can lock away traces of synthetic compounds for millions of years. Among the most telling signatures might be plutonium-244, an isotope with a half-life of 80 million years. On Earth, it exists today, only in vanishingly small amounts, produced naturally only in rare astrophysical events, like supernovae. Its detection in concentrated form would be difficult to explain without advanced nuclear technology. The oceans guard another possibility. During ice ages, sea levels fell dramatically, revealing vast stretches of coastal plains that could have supported civilizations. Those lands are now drowned, buried beneath sediment, or dragged into deep trenches by the slow conveyor belts of plate tectonics. Modern sonar mapping can detect unusual patterns on the seafloor, while submersibles can collect samples, but the scale is immense and the probability of finding a single buried city from a forgotten epoch is small. Yet even one fragment would be enough to rewrite human history. The search increasingly depends on artificial intelligence, which can scan vast geological data sets for patterns invisible to the human eye, unusual clusters of isotopes, layers containing unexpected combinations of compounds, or sequences of heavy metal spikes followed by sudden collapses in biological diversity. These might be natural, or they might be footprints in the deep past, left by something that once lived and built, then disappeared. This is not a hunt for monuments. It is a hunt for whispers in the static of deep time, faint lines of code hidden in the planet's memory. Even if such a signal were found, we might never know its full story. Was it the work of beings shaped by flesh and bone, or something utterly alien to our imagination? Did they wonder about the stars as we do, or did their gaze never leave the oceans or forests of their homeworld? Somewhere in the silent depths of the oceans, in the locked vaults of stone beneath our feet, the answer may already be written, but to read it will require patience measured in lifetimes. The Earth keeps its secrets well, and those who seek them must accept that the truth, if it exists, may be too deeply buried for any of us to hear it. The deeper the investigation went, the more the enormity of the challenge revealed itself. Evidence, if it ever existed, would have to survive the most destructive forces the planet could unleash. And those forces have no mercy for memory. In the span of millions of years, Earth has rewritten itself again and again, each chapter erasing much of the one before. Civilizations, if they rose, would have faced not only the slow erosion of time, but cataclysms on a scale that leaves no survivors, no monuments, and no trace recognizable to those who come after. Asteroids have struck with the power to boil oceans, ignite forests across continents, and darken skies for years. One such impact, 66 million years ago, ended the reign of the dinosaurs. If a technological society had stood anywhere on Earth that day, it would have been obliterated in an instant. The heat pulse alone would have turned cities to glass, the shock wave would have leveled continents, and the global fires would have consumed anything left standing. In the aftermath, even the ruins would have been erased, buried under layers of ejecta and ash, their outlines lost forever to the slow grind of geology. Supervolcanoes have erupted with equal devastation. The Siberian traps, 252 million years ago, poured out enough lava to cover millions of square kilometers, releasing greenhouse gases that triggered the largest mass extinction in the planet's history. A civilization caught in that fury would have had no chance to preserve its story. Its artifacts would have been swallowed by molten rock, its landscapes flattened into featureless plains of basalt. Even without such cataclysms, the Earth itself is restless. Plate tectonics acts like a planetary conveyor belt, dragging entire continents into the mantle and replacing them with new crust. Over tens of millions of years, every surface is recycled. Oceans open and close, mountains rise and fall, and whatever was once on the surface is consumed into the depths, transformed beyond recognition. The ocean floor is even less forgiving. In the deep trenches, vast slabs of crust are pulled downward and melted, taking with them any secrets they carried. Structures that once stood on ancient coastlines would be ground into magma, their existence reduced to nothing more than a memory the Earth never shares. And yet, perhaps the most chilling thought is that destruction does not need to come from without. Civilizations can collapse by their own hand, drained of resources, poisoned by their own industries, or destabilized by the very systems they depend upon. If this happened in the distant past, the aftermath would have been a slow vanishing. First the cities, then the roads, then the faintest traces of human-like order, each succumbing to vines, sand, and the unhurried patience of the elements. In time, all that would remain would be a few stubborn signatures buried in the geological noise, indistinguishable from nature's accidents. This is the escalation the Silurian hypothesis forces us to face. It is not only a question of whether intelligent life arose before us, but whether such life could ever survive long enough to leave a permanent mark. Against the backdrop of deep time, even our most ambitious monuments are brief flickers. The Great Pyramid, untouched, might last for tens of thousands of years. But in 1,000,000 years, its stones would be scattered. In 10 million, the shifting crust might have buried or destroyed it entirely. If our species vanished today, it is possible that in 100 million years, nothing would remain of us but a thin layer of altered minerals, a chemical whisper buried in rock. The Fermi paradox, often phrased as "where is everyone?" gains a new and haunting dimension. The question is no longer only about the silence of the cosmos. It is also about the silence of our own planet's past. Perhaps the reason we find no one out there is the same reason we might find no one here. Civilizations may burn bright, but briefly, and their light may fade before it has a chance to travel far. To ask, "Where is everyone?" becomes to ask, "Where were they here?" And the answer may be that they are gone, as we too may one day be gone, leaving behind only the faintest, most fragile trace, waiting for some future intelligence to wonder if it ever truly meant what they think it meant. If the possibility of a forgotten civilization is to be taken seriously, then the question shifts from whether it left traces to how such a civilization could have come to be. In the great theater of Earth's history, the stage has been reset many times, and evolution has repeatedly filled it with new actors. Intelligence, as humans define it, is not an inevitable outcome. Yet nature has produced it more than once, in primates, in cetaceans, in certain birds, whose tool use rivals that of our distant ancestors. Over spans of tens or hundreds of millions of years, there may have been room for something more, something that walked a path we can only guess at. One possibility is that another branch of life, entirely unrelated to humans, rose to technological mastery. In the lush forests of the Carboniferous, when oxygen levels were higher than today, and insects grew to the size of hawks, could some vertebrate lineage have developed complex cognition? Or in the warm oceans of the Cretaceous, could a marine species have built a civilization not of stone and metal, but of materials now lost to decay? Evolutionary history shows no shortage of candidates that, given different pressures, might have taken unexpected turns. Another theory draws from the cyclical nature of catastrophe and recovery. Mass extinctions erase dominant species, but they also open ecological niches, setting the stage for rapid diversification. It is conceivable that more than once, intelligence surged forward, only to be cut down by an asteroid strike, a supervolcano, or a global climate shift. Each time, the survivors would inherit a changed world, and the slate would be wiped clean of those who came before. Some have speculated on even stranger origins. If Earth has been visited by extraterrestrial explorers not as a matter of fantasy, but as a statistical inevitability in a galaxy of billions of worlds, could one of those visitors have seeded the planet with technology or knowledge? Could an alien presence have established a foothold here long before the first humans, only to vanish or depart, leaving behind faint traces buried in time? Such an idea is impossible to confirm and dangerous to romanticize, yet it remains within the realm of what cannot be ruled out entirely. There is also the possibility that the trajectory of such a civilization was unlike ours. We build in ways that resist decay. Metals, stone, plastics. But an advanced society might have embraced biodegradable materials entirely, leaving almost nothing for future ages to find. A technological culture made of organics, wood, and fibers could vanish far more completely than one of steel and concrete. Its cities could be gone in centuries, its tools in decades, its memory in the turn of a geological page. In examining these possibilities, scientists return again and again to the idea of the Anthropocene, our own layer in the rock, the signal we are leaving for the far future. We imagine it as a unique mark, the sign of the first and only industrial civilization on this planet. Yet if deep time can erase nearly everything, then the Anthropocene may not be the first such signal. It may only be the most recent. The layers beneath us may already carry the faint ghosts of earlier epochs, compressed beyond recognition. Theories about such civilizations must wrestle with one core problem: the absence of direct artifacts. Without physical structures or tools, without inscriptions or art, interpretation becomes perilous. A carbon spike in the geological record could come from human industry or from a massive volcanic event. Anomalous isotope ratios might point to nuclear technology or to rare but natural processes in the deep earth. Even the presence of synthetic compounds would need extraordinary evidence to separate them from contamination by more recent ages. Yet speculation has its value, not as proof, but as a way to test the limits of our perception. By asking what signs a past civilization might have left, scientists refine the methods for detecting any kind of technosignature, whether on Earth or on distant exoplanets. The same tools that might one day reveal a forgotten chapter in our own past could help us recognize industrial activity on a planet orbiting another star. The search is not bound by time or location. It is a study of what it means to leave a mark in the universe. The most sobering speculation is that civilizations, even advanced ones, might be common in time but rare in persistence. They may rise quickly, transform their world, and disappear in a fraction of a geological moment. From the perspective of the cosmos, they are brief flashes, like lightning on a dark horizon. If that is true, then the silence in the stars is not a mystery at all. It is the natural state of things. And if it is true here, on our own planet, then our place in the story changes. We are not the first intelligence to gaze at the stars, but perhaps the latest in a long and fragile lineage. The possibility is humbling. It suggests that the measure of a civilization's greatness is not its power, but its ability to endure, to leave something behind that cannot be erased by fire, water, or time. The Silurian Hypothesis does not claim that such a civilization existed. It does something subtler and perhaps more profound. It reminds us that history is not a straight line, but a cycle, that the Earth's memory is incomplete, and that even here, on the world we call our own, there may be entire stories buried so deeply that they will never be told. The tools of this search are as varied as the questions they seek to answer, and each is designed to listen for whispers in the deep archive of the planet. In quiet laboratories and aboard ships that drift above the deepest parts of the sea, scientists are gathering data not to prove a lost civilization existed, but to measure the limits of knowing. Their instruments are tuned to find what the eye cannot see, and the hand cannot touch signatures that exist only as arrangements of atoms, patterns in isotopes, or subtle chemical anomalies spread thinly across the crust of the Earth. From orbit, satellites map the contours of the land and the ocean floor with laser precision. These images can reveal the straight lines, right angles, and geometric patterns that nature rarely produces on its own. Such data is pored over for anomalies: an unexplained ridge in a deep basin, a sunken terrace that could once have been shoreline architecture, a buried grid beneath a desert plain. Most turn out to be geological accidents, the work of wind, water, and tectonics, but each one must be examined for the rare possibility that something artificial lies beneath. Beneath the surface, core samples tell a slower story. Drill ships designed for oceanographic research lower hollow cylinders into the seafloor, retrieving columns of sediment laid down in layers over millions of years. Each layer is a page in the planet's memory, storing fragments of the environment at the time it was deposited. The pollen of vanished forests, the shells of microscopic plankton, the trace gases that drifted through ancient skies. Within these layers, scientists search for chemical compounds that nature does not make in quantity, specific halogenated organics, persistent plastics reduced to microscopic fragments, Isotopes shifted from their natural balance by industrial processes. These are the clues that could outlast cities, pointing to an era of technology long gone. On the ice sheets of Antarctica and Greenland, other teams drilled deep into frozen time. Ice cores preserve the air itself, sealed in bubbles since the day it was trapped. By studying their contents, researchers can reconstruct the atmosphere of past ages in remarkable detail. They can see the rise and fall of carbon dioxide, the traces of volcanic ash, and the fleeting fingerprints of rare events. A spike in greenhouse gases without a clear volcanic cause or the sudden appearance of heavy metals could point to industrial activity. Yet the reach of the ice is limited. Its record fades into nothing beyond 1 million years, leaving most of Earth's deep past inaccessible to this line of investigation. In the deep ocean, remotely operated vehicles glide through black water, guided by sonar and lights that pierce only a few meters into the void. They collect samples from slopes and plateaus where ancient coastlines once stood. These were the frontiers of life during lower sea levels, and if civilizations once flourished there, their remains could now be hidden under layers of sediment. The challenge is scale. The oceans are vast, and each expedition covers only a fraction of a fraction. Still, every recovered object, every strange formation on the seabed, becomes a clue to be examined under microscopes and chemical analysis. On land, geophysical surveys use ground-penetrating radar and magnetometry to search for anomalies hidden beneath soil and stone. These techniques can detect buried structures, dense materials, or voids where nothing should be. Archaeologists use them today to find human ruins only thousands of years old. In principle, they could find something far older, though erosion and geological upheaval make that a remote hope. Increasingly, the search relies on artificial intelligence to make sense of overwhelming amounts of data. Machine learning algorithms are trained to recognize patterns too complex or subtle for humans to spot statistical irregularities in isotope ratios, unexpected alignments in topography, correlations between distant core samples. By comparing data from across the globe, AI can flag anomalies that might represent something more than coincidence. It cannot tell us what they mean, but it can tell us where to look. Physicists also turn their attention to isotopes that can survive deep time. Plutonium-244, with a half-life of 80 million years, is one such candidate. If it were found in unusual concentrations in ancient strata, it might suggest nuclear technology in the deep past. Similarly, the presence of certain stable synthetic elements could be nearly impossible to explain through natural processes alone. These would be the rarest of signals, but also the most convincing, for nature does not forge such materials lightly. The work is slow, and its results are uncertain. Years of study may end with nothing more than the conclusion that the record is silent. But silence does not mean the past was empty. It means the past is well hidden. And, in the language of science, a well-hidden past is a challenge, not a surrender. The same tools used in this search are shaping how we look for life beyond Earth. If we can learn to detect the faint industrial signature of a civilization erased from our own planet, we might recognize it on Mars, beneath the ice of Europa, or in the light from a distant exoplanet. The questions asked by the Silurian Hypothesis do not end at Earth's surface. They extend into the galaxy, transforming our search for extraterrestrial life into a search for the marks that time cannot easily erase. Every drill core, every spectral scan, every sonar sweep is a step into that darkness. Each is an attempt to read a message that may never have been written, or that was written in a language we no longer understand. The work is meticulous, patient, and humbling. For the scientists engaged in it, the pursuit is not about proving that ancient civilizations existed. It is about testing the boundaries of what is knowable and learning whether, in the end, the Earth's deepest secrets can ever be brought into the light. The search ends not with answers, but with the realization that perhaps no answer will ever come. The Earth is older and more patient than any species that has walked upon it. It carries our weight for a moment, then folds us into its slow, unbroken cycles. Civilizations, no matter how brilliant, are short-lived flares in the darkness. The rock does not remember their names. The seas do not recall their songs. If there was another before us, it lived its span and fell into silence. Its monuments became mountains. Its cities became sand. Its machines became elements, scattered in the wind and rain. Perhaps it burned brightly, reshaping the world in ways that echoed for an age. Perhaps it was gentle, its presence light upon the land, leaving no mark but its absence. Whether it ended in catastrophe or faded quietly into extinction, the outcome was the same. The unsettling truth is that we, too, will vanish. Whether in centuries or in millions of years, our cities will fall, our books will crumble, and our stories will dissolve into dust. The Anthropocene, the bright line we are drawing in the planet's archive, will compress into a layer no thicker than a finger's width. Whatever survives will not be our languages or our music, but a scattering of isotopes, fragments of plastic, a whisper of carbon where the curve of the climate changed. And if, in some far future, another intelligence walks this earth, it may study those traces as we study the strata beneath our feet. They may wonder who we were and whether we were alone. They may ask the same question we ask now. Were we the first? They may never know the answer. The Silurian Hypothesis is not a story about what was. It is a reminder of what can be lost. It asks us to see ourselves against the vast canvas of deep time, to understand that our presence here is neither permanent nor guaranteed. We stand in a brief and fragile moment, the product of countless accidents and extinctions, holding the capacity to shape the planet and the capacity to erase ourselves from it. Perhaps the greatest legacy we can leave is not our buildings, nor our machines, nor our chemical fingerprints in the rock, but a future in which our story is remembered. To endure in memory is to defy the silence of time, to resist the tide that erases all that stands before it. But memory, like civilization, must be tended. It must be passed forward with intention, or it too will be lost. Somewhere in the rock beneath us, there may be a page we will never read. Somewhere in the ocean's depths, a fragment may lie waiting, holding the final proof that we were not alone in Earth's deep past. And perhaps that fragment will never be found, because the planet has chosen to keep it secret. Or perhaps it will be discovered by hands that are not our own, in an age when our story is already over. If that day comes, they may see us only as a shadow in the stone, a line in the archive, a fleeting signal in a billion years of silence. And they will ask the same question we ask now, their voices carrying it forward into the endless corridors of time. What if we were not the first intelligent life on Earth?